discuss lesson 2, which is the balanced strategy for solving equations. So we're going to model linear equations using a balance beam this side. Now, with the balance beam, there is one thing we have to remember, is with the balance beam, all terms must be positive. So all terms, please write this down, must be positive. Okay, so all terms must be positive. Can we get a negative answer? Sure we can. But we're not going to have negatives to start with. Okay? So, we're now going to have, so this is like a 3D object that they're showing you in 2 dimensions. You're looking at this balance beam from the front. So these are our long rectangle x's. These are these guys, but you're looking at it like this. Okay, so you're only seeing the little square right here, okay, of the actual stick. So that's what's going on right there. So that's why they've decided, since they use this as a square, they've decided to say, well, that algebra tile that we've been using as a little square, they've now turned it to a circle so that you don't get it confused. Okay? So this is only for the balance beam. So what they do is they put the correct amount of x's on both sides. Now this is like the 0 pairs thing, guys. All we've got to do, seriously, is grab our pencils and cross off the same amount on both sides. How many x's can I cross off on both sides? 5, exactly. So that means all of those go, and I can take 5 of those off. Okay, and how many am I left with? 2, good. So now I've got 8. So I've got 8 of these guys, and now we're going to put them in a row. And I'm going to show you why. We're not going to put them up and down as a column. We're going to put them as a row. And why do you think I'm making 2 rows of 4? Can anybody tell me why I've decided to make 2 rows of 4? Yeah? You're exactly right. 4 plus 4 equals 8. And then I get all of my 8. There's also another reason I did that. Because I've got 2 x's over here. Now, when we solve on the balance beam, we put everything that we have left over. So we're drawing your circles here and our 2 squares. Now what we do is this is our dividing step, our last step. So we would say 8 equals 2x if we were to write it out. What would my last step be here? Divide by what's sitting beside x. So I would divide out the 2 beside x to both sides, correct? So what should I get my answer to be? 4. Right. So we would get our answer as x equals, whoopsie, I wrote a 3. He's equal to 4. Now, if we take a look, what would happen if I drew a line and cut them through the middle? What does it show? It shows x equals 4. Pretty cool, hey? All right. So anytime that we are using the balance beam strategy, they will at first draw them in stacks of towers. Once they've done the stacks of towers, and you've removed all the x's that you can from both sides, and sometimes there's circles you can remove from both sides. So once you've done all of that, then you put them up like this, and you divide down the middle. Okay? We're going to do another example like this, just to see what we're doing here. We're going to add some circles on both sides now next. Okay? So let's look at the bottom of your page. So now we've got some circles on both sides, and we've got squares on both sides. So what can I get rid of on both sides? Hands up. Who knows what I can get rid of on both sides? What can I get rid of? Okay. Skittles? Yep.
3.
3 what?
3 plus 3 x's.
Okay, perfect. So we're going to get 3 of the circles. Okay, so 3 constants are going to go away. And then I'm going to take 3 constants away up top. Okay? Now she also said we've also got 3 x's on both sides that can go away. So I'm going to take my 3 x's out, and I'm going to take my 3 x's out. Now, we're going to write what we've got left over. So I've got an X and an X, and we're going to make them towers. And now I've got a circle and a circle. Am I going to just make one big long row of 4?
No.
Well, then what am I going to do?
2 on top, 2 on the bottom.
2 on the top and 2 on the bottom. Now, can you tell me why we're doing this? Exactly. I'm going to put a line through them to divide them. And in order to divide them, they have to have an equal amount on both sides. So that's why we divide them up so they're equal. And how much does it tell us X is equal to this time? 2. Good. So, how did everybody like the balance beam? Not too bad?
I like
Yeah, balance beam's pretty good. But what are we remembering? The balance beam always has to have an answer of positive numbers. Well, this answer could be negative, possibly. But these numbers up here will all have to be positives. They're not going to put a negative one on there. Okay? And why do they do that? So you can get rid of these guys on both sides. Okay? That's why they do it. Let's take a look at a different example. So this one says, solve the following equations algebraically and verify your answer. So we've now learned 3 ways to solve equations. We have learned inverse operations, which is adding the opposite. Okay, so doing the opposite function across the equal sign. And we've also learned the balance beam, if they're all positive. And we've also learned how to do what? The box strategy. Okay? But the box strategy only works if X is on one side. Do we have a variable only on one side here? No. So that means we can't use the box strategy yet. We have to move our variable to the left. So we're going to move all these ends to the left-hand side. Okay? Now, if you wanted to, you could draw your picture. You could have 10 squares on your balance beam. We're going to pretend we have a balance beam here. And let's see, triangle. And then we need, and now I'm going to draw circles. Holy, that's a lot. Okay, so we can do it this way very easily because they're all positives. How many can I take away on both sides? How many of the big red squares do you see here I can remove?
5.
5, thank you. Yes, we're going to remove 5. So we're going to scribble 5 of them out. There goes 5, and there goes 5. Okay, they're gone. What can I take away from my circles? 6, thank you. So we're going to get rid of 6 circles on both sides. So 2, 4, 6. All right, we got rid of our circles. So what do we have left over? 1, 2, 3, 4, 5 boxes. So we could say 5 X's or N's, whatever you'd like. And then what do we have left over here for digits? Little circles. 10 little circles equals 10. I just ran out of room to draw. So if I were to draw those would look like circles. We would have it look like this. I'm just going to put it on the right-hand side. We would have 5 X's. And then we're going to have our circles. And we're going to go 2, 4, 6, 8, 10. Now, how many times can I cut this through and divide? I get to cut them through every time. So what do I get for an answer? How big is X?
2.
Look how many we've got here.
2.
2, I have 2 here. So we're going to get X equals 2, or in this case it's N. Okay? Now we're going to verify, but we're going to verify with numbers and letters. Okay, we're going to do numbers and letters in here. Okay, so I'll let you get finished writing this down, and then I'll do the verify. Okay, we are now going to verify our solution. We have X is 2. So everywhere where we see our N, we see where the N value is. We're going to put our 2. And of course, we always substitute using brackets. Okay. So brackets in this case are going to tell us to multiply. So we're going to do bed math. We have to multiply first, and then we're going to add. We make a line down our equal sign because remember, we're trying to see if the left side equals the right side. Because if it does, that means we did it correctly. So over on this side, we're now going to get 26. We're going to do bed math on the right-hand side now. So the 16 is going to come down, and we're going to take 5 times 2 and get a 10. And now we have to add 16 and 10, and we're going to get 26. Does our left side equal our right side?
Yes.
It does so that means we did it correctly. So left side equals right side. So we did it correctly. Okay? All right, let's take a look at the last couple questions.
I guess so.
Okay, let's moving on to the next question. We have letter C here. So this one, we cannot use the balance beam. Why can't we use the balance beam?
The negatives.
Yes, because of negatives. Ugh. Okay, so now, so that means we cannot use balance. We are going to use the inverse strategy. We could also use the box strategy after we move the letter C to the left. So our very first thing we have to do is move that 2C to visit the other C's. He's on the wrong side. We always want the variable to move to the left and the constants to move to the right. So guys, left variables. So he is a positive. How do I create a zero pair? Right now he is a positive 2. How do I create a negative?
What? You got it. Just go over to the other side.
Yep, you just said it.
Yes. We're going to do a zero pair. So what do we have to do to a positive 2 to get it to remove? A negative 2. Yes. So we're going to subtract 2 C's. We're going to subtract 2 C's here. Now we're going to add like terms. So we're going to take all of those and add them up. If we add them up on the right-hand side, what happens? They disappear. It's a zero pair, so they disappear. So now we're going to add like terms over here, which is going to give us negative 5C's plus 7 equals negative 8. Okay?
So the 2 has to visit the 3?
That's right. The 2 has to visit the 3 because he has a stick. He has a C.
And
Okay?
did that happen in the last one?
It sure did. It will happen in every situation. So the variables will always move to the same side as the variables. And the constants will always move to the same side as the constants. Okay? That part will never change. Now we're going to move the 7 to the right. And the reason we're moving them over is why? Because he doesn't have a variable. He's on the wrong side. He's crowding all the C's. We want only variables over here. So this guy's a constant. He has to remove. So we're going to zero pair, subtract 7 to the other side. If we don't do it, we've unbalanced. We have to do it to both sides. So that's going to make our zero pair here, and it's going to disappear. Now we're going to have negative 5C equals negative 50. Okay? Our very final step, who can tell me what we're going to do very, very, very last?
5, 5, 5. Wait.
By a positive 5?
Negative.
Negative 5. Okay.
Ooh, 8.
So we're going to divide by exactly the digit sitting beside the variable. So we're going to divide by negative 5 to both sides. That's going to divide and become our hidden positive 1 in front of our letter C that we want. So we're going to have 1C equals, now we've got a negative, divided by a negative is a positive 3. So C is equal to positive 3. That is our final answer.
I knew that.
Now we are going to go and make sure that that is a true solution. So we have to verify it. So that means we're going to substitute our answer. We're going to put that 3 where all those C's are. Okay? So we're going to draw a line down our equal sign. And now we're going to draw the equation with brackets, where the variable is. Okay, so you're going to see I put brackets where the variable is, and that's where we are going to put our number. So how big did we find our variable to equal? 3. So we're going to put the 3 in that highlighted bracket that I showed you. Now we're going to do BEDMAS on both sides. So we're going to multiply here. We're going to get negative 9 plus 7. And over here, we're going to get 6, subtract 8. Now we're going to add over here. We're going to get negative 2. We're going to add on the right-hand side, and we get a negative 2. So that tells us we did the question correctly because the left side, the left side is equal to the right side. So we did it correctly. Okay? You are going to have a couple questions that I'm going to give you a couple minutes to do. So the next page is a few questions I'd like you to do. Push pause now and play when you're ready. Okay, you've had a couple minutes to work on your questions. We are going to introduce a guest speaker. Okay, Miles, take the question.
Okay. So first of all, we got to change this to come over here, and we got to turn it into a negative so that it cancels out. So that would be negative 7g plus 2 equals negative 12. And then we got to minus the 2 to cancel that out. And we got a negative 2 here to make that a negative 14.
Why did we do that, guest speaker?
Oh, because we did it here, so we have to do it on the other side.
You're exactly right. Thank you.
Then we go negative 7 equals negative 14. And then we got to divide by negative 7, cancel that out, divide this by negative 7 to give that positive 2.
Very well done.
Positive 2.
Thank you very much, guest speaker. Okay, we're just going to verify Miles' solutions. We're going to put in where our G is. We're going to put our answer of 2. So, where the G is, we are putting our positive 2. And now we're going to see if our left side equals our right side. Doing BEDMAS, we're going to get a negative 10 plus 2. On this side, we are going to get a 4 subtract 12. Negative 10 plus 2 gives us a negative 8. 4 subtract 12 also gives us negative 8. Our left side does equal our right side, which means we did the question correctly. On the bottom of the page, you have a couple questions that look like they have a variable on the bottom. Now, we already know that we can't give them the special name of polynomial, but we can still solve them. What is the rule? For example, if I were to change the question and said I had x over 4 equals 2, how would I get the 4 off the bottom? Any ideas? What would we do to get the 4 off the bottom? What are we going to do? You guys are right. We're going to multiply to get rid of it. So, same idea. We would multiply this guy, multiply it over here. We're going to use that same process here. We're going to multiply the n to both sides. That's going to remove it for us. Now we're going to have 122 equals 3n's. Now the reason they have n cannot equal 0 sitting there, that's because the variable started on the bottom. Now if you take your calculators and you go 122 divided by 0, it's not going to do it for you. It's going to say error, okay? It won't do it because we're not able to divide by 0. So that's why whenever you've got a fraction, there will usually always be something that tells us that we cannot divide by 0 right here. Okay, that's why that's there. It'll be here on purpose as well, cannot divide by 0. Okay, so our last step is going to be to divide by our 3, the same process we would to do any other solving for variable. We have isolated our variable now, so now we're going to get a decimal answer. N is equal to how big? Do it in the calculator. How big is n? 40.6.
Repeating.
All right, 6 repeating, exactly. Okay, so what we're going to do now is we're going to do the exact same thing to b. So you guys do b real quick. Do the exact same thing to that letter p. We're going to move it over to the other side, multiply it out, just like we did. Okay?
Wow.
Okay, so you should get negative 2p's equals 12.5. Divide out your negative 2. It disappears. Negative divided by negative gives us our hidden positive 1 in front of our p. That's what we want. Equals negative 6.25. Good job. Okay. This concludes lesson 2.